Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be studying Section 7 of Chapter 1, Absolute Value Equations. So a little bit of background information first that you want to copy in your notebook. Absolute value is the distance a number is from zero. Now since you cannot go a negative distance, distance is always represented by a positive number. So if absolute value is distance, when we take the absolute value of a number, the absolute value will also be positive. Now, to know if we are dealing with absolute value or not, we look for the following notation: two vertical bars with something in between them. So these vertical bars tell us that we're looking for the absolute value. So our first example says to find the absolute value of -5. When I find the absolute value of a number, I think about where it is on a number line. So for the first example, the absolute value of -5. If I want to figure out the absolute value of -5, I'm going to think where -5 is on the number line, and I'm going to count how far away is it from 0. So 1, 2, 3, 4, it's 5 units away from 0. So since the absolute value is a distance, and distance is always positive, we would say the absolute value of -5 is 5. Now, repeating that process with the second example, this time I want to know the absolute value of +5. So again, thinking about a number line, and you don't have to draw the number lines, I just use them as a nice visual. We would start at 5, and we want to figure out how far away is that number from 0. So 1, 2, 3, 4, it's 5 units from 0 as well. And since absolute value again is distance, and distance is positive, we would say the absolute value of 5 is also 5. So our next example says the absolute value of x equals 5. So when we are trying to figure out what the absolute value is taken of, more than likely there's going to be two answers because you have numbers to both the left and the right of 0 that are the same distance away from it. So when I set up these problems, what I do is take what's on the inside of the absolute value bars, in this case x, and I write it down 2 times. So I'll say x equals and x equals. And then I'll write down both the positive and negative of the number that the absolute value is equal to. So in this case, since the absolute value is equal to 5, I'll say that x could have been +5, or x could have been -5. Because if I figure out the absolute value of +5, that's 5, and the absolute value of -5 is also 5. Now, the fourth example says the absolute value of x equals 0. So if I follow that same process, I'm going to take what's inside the absolute value bars and say x equals 2 times. And I'm going to say that x would equal a +0 and x would equal a -0. Now you might be asking yourself, a -0? Well, there is no such thing as a negative or positive 0. So on this one, we're not going to set 2 zeros of positive and negative. We're just going to say that x is equal to 0, because the only time that we are 0 units away from 0 on the number line is when we are at 0 itself. So example 4 is the only time you're going to get one solution for absolute value problems, only if the absolute value is equal to 0. So now we're going to take a look at solving absolute value equations. So there's a set of steps that we need to follow. The first thing is to isolate the absolute value. We want the set of bars to be the only thing on the left or right hand side of the equation. So we have to get those by themselves. So if there's something being added to the absolute value bars, then we'll need to get rid of that. If there's something being multiplied or divided with the absolute value bars, we'll need to get rid of that. Once we have the absolute value bars isolated, then we move on to step 2, where we write 2 equations, one where the inside equals a positive number and one where the inside equals a negative number. Once we write our 2 equations, the final step is to solve those 2 equations. So let's take a look at solving absolute value equations in practice. So our first example of solving equations is example 5. Find the absolute value of 2x minus 3 equal to 1. So we first want to make sure that the absolute value is isolated. That means it's completely by itself on one side. So if we take a look at this first problem, the 2x minus 3 is the only thing on the left-hand side of the equal, so it is isolated. The other thing we want to check is to make sure that it is equal to a positive or 0. So this is equal to a positive 1, which is good. So we can continue solving this problem. So what I'm going to do when the absolute value is isolated, I'm going to take what's on the inside, and I'm going to set that equal to both the positive and negative of the number on the outside. So I'm going to say that 2x minus 3 could be positive 1. I'm also going to say that 2x minus 3 could be negative 1, because the absolute value of positive 1 and the absolute value of negative 1 both produce 1. So you have to set up two equations. Once you set up the two equations, we solve them. So for the left equation, I'm going to add 3 to both sides. That's going to give me 2x equal to 4. And then I'm going to divide 2. So x equals 2. Solving the second equation, I'm going to do the exact same process, but my one number is different. So if I add 3 to both sides, I'll get 2x is equal to 2. And when I divide 2, x is 1. So my answers are 2 and 1. Now, when we solve absolute values, you normally won't see it as x equals this and x equals this. You'll see them written in between two swiggle brackets. So draw the swiggle brackets as best as you can. I'm not going to judge your drawings, but the more you do it, the better you'll get. So in between two swiggle brackets, we'd say 2, 1. The answers to example 5 were 2 and 1. Looking at example 6, we have 7 equals the absolute value of x plus 2. So the first thing we want is for the absolute value to be all by itself. In this case, the absolute value is not all by itself. It has a 2 being added to it. So we're going to have to get rid of the plus 2 by subtracting 2 on both sides. So we're going to have 5 equals the absolute value of x. Now, I like the absolute value on the left side of the equal, so I will rewrite these as the absolute value of x equals 5. You are not required to do that. That's just how I like to see it, personal preference. And now that the absolute value is isolated, I will solve this equation. So I'm going to take what's on the inside x, and I'm going to say that could equal positive 5. Or the inside x could equal the negative of that 5, negative 5. So when I write my solutions to this problem, I'll put them in the swiggle brackets and I'll say 5 and negative 5 were my solutions. And our last two examples. Example 7 says 2 times the absolute value of x plus 5 equals 4. Now, absolute value bars do not act the same as parentheses. So you cannot distribute the 2 into the x and 5. The absolute value bars protect what's inside. So what we want to do is get the absolute value bar part all by itself. So right now, since the absolute value is being multiplied by 2, we need to undo that by dividing both sides by 2. So when I divide by 2, I'm going to be left with the absolute value, x plus 5, equal to 4 divided by 2, which is 2. So I want to make sure, number 1, the absolute value is isolated. It's all by itself. In this case it is, because it's the only thing to the left of the equals. Once I make sure the absolute value bars are isolated, then I want to make sure I equal either 0 or a positive number. because the absolute value will always give you 0 or a positive number. You will never get a negative number since it represents distance. So in this case, we're good because it equals positive 2. So I'm going to say the inside x plus 5 is equal to 2, or the inside x plus 5 is equal to negative 2. And then I solve each equation. So I'm going to subtract 5 on both sides. So x is negative 3. And then the second equation, I'm still subtracting 5, but the one number is different. So negative 2 minus 5 is negative 7. So our final answer in the brace is negative 3, negative 7. And our final example, example 8, says 3 times the absolute value of x plus 6 plus 8 is equal to 5. So the first thing that I want to do is get the absolute value bars isolated. Right now, there's a 3 and an 8 with the absolute value bars. So what I like to do is think about this as if it were to say 3x plus 8. I'm letting the absolute value bars just be represented by 8 right now. If this said 3x plus 8, think about what you would do to get x by itself first. Would you remove the 3 or would you remove the 8? If you said remove the 8, you would be correct. So to solve this absolute value equation, we're first going to get rid of the 8. So we'll get rid of the plus 8 by subtracting 8 on both sides. So when I subtract 8, I'm going to be left with 3 with the absolute value of x plus 6. And 5 minus 8 is negative 3. So once I get that part gone, then I still have to get rid of the 3. So again, we're not going to distribute it inside the absolute value because the absolute value bars are protecting it. So since it's being multiplied, I'm going to divide both sides by 3. When I divide by 3, I'm going to be left with the absolute value of x plus 6. And negative 3 divided by 3 is negative 1. So I have the absolute value of x plus 6 equals negative 1. So when I have the absolute value bars isolated, I want to make sure the absolute value is equal to either 0 or a positive number, because absolute value is distance. In this case, it says the absolute value is going to be negative 1. Well, since the absolute value is distance and distance is always positive, this is never going to happen. You are never going to get an absolute value equal to a negative number as the final result. So since this will never happen, we will say that this one will have no solution. Now, do not confuse that with getting negative answers. The previous example, example 7, you can see negative answers were quite possible as we solve the equations. This is just saying that the absolute value bars can never be equal to a negative number. This concludes our lesson on section 7 of chapter 1, solving absolute value equations. If you have any questions, please ask Miss Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Miss Brooks.